at least continue from where I stop. Yeah, from where I stopped. You all know where I stopped, if I'm not mistaken. True or false? So let's start from where I stopped in this particular question. You know, in this particular problem, we stopped and we sought to stop at this particular point. You know, this was a problem that find the Laplace transform of the function that is f of t equals to cos at. So of course, yeah, this was the question given, and so far in our first video of this particular question, we sought to stop here. Then we want to further from here. So let us clean and continue from where we stop. You know, I told us that to continue from where we stop, we are still going to make use of integration by parts. Two of us. It's true, right? I will still make use of integration by parts. Two of us. It's true, right? Okay. So let us proceed to use. It means for us to obtain here, I will use the integration by parts. So let's make use of integration by parts. The formula is using by parts here. By parts, if you check the first video, you will see where we solve to stop. We stop here. So by part is integral u dv is equals to uv minus integral v du. Amen? Yeah. That is simple as ABC. Okay, so now what this formula will only consider this function. Forget about what is here. So you hold this one as constant. So this formula will only consider this. So for us to continue with this, we are going to say let u be equals to sine 80 and the v. Look at it, the v should be equals to exponential minus st dt. Why are we doing this? Because in the formula, we have our ordinary u and ordinary v. Then we also have our ordinary v and the u. So now we have gotten our ordinary u as letting u equals to sine 80 and our dv letting this to be. So how can we obtain our du? By differentiating this with respect to what? T, two of us. So when we differentiate this with respect to t, it means du all over dt, and then we're going to give us a cos 80. Then by the time we cross multiply our du, we can obtain our du as a cos 80 dt. Amen. Please don't forget to share, like, comment this video. What you are watching, is that clear? Share with your friends and loved ones. Do you understand? Are you following? Okay. So if you agree with me, it means let us continue to look at it together. Amen. So then here To obtain our ordinary v, we integrate this both sides with respect to t. If we integrate the v, we are going to have ordinary v equals, if we integrate exponential minus st, we are supposed to have minus exponential minus st all over what? S. Amen? Okay, so far so good. What we need to do here is for us to substitute this into this formula. So it implies that I told you we hold this one constant. So we just after integral 0 to infinity, amen. Then here will be sine at exponential minus st dt. Yeah. So this is equals to, amen. This is equals to, what is our ordinary u? Our ordinary u is sine 80, true or false, times what is our ordinary v minus exponential minus st all over s. So we are supposed to write it this because of the negative sign, minus sine 80 times exponential minus st all over s. Amen? True or false? It's true, right? Okay, yeah. So what we have here, minus. But mind you, we have a definite integral running from 0 to infinity, then minus integral 0 to what? Infinity. Amen? Ordinary u is what? V, sorry, is minus exponential minus st all over s. Amen? Then what is our du? Du is this times a cos 80 dt. Do you agree with me on this point? Any question, please? Do you have any question? If you have any question, please ask. I'm waiting. Any question? No question. Okay, so it means we can proceed, right? Okay, yeah. This is what, we are trying to solve our first problem we solved this morning. It means this one is part 2 of that particular problem. Yeah. The problem says find the Laplace transform of the function. Amen? Of the function, yes, f of t equals to cos 80. That is the problem. I think if you check the first video, you will see it. Okay, so now let us proceed further, amen, to look at it together. So it means we are going to do something here. We will subtract lower limit from the upper limit here. True or false? It's true, right? True or false? It's true, right? Okay. Please don't forget to like, share, and comment. Exactly. So now what we need to do here is, let's do something here. Here will be minus sine 80. So sorry, anywhere we see t, we substitute in infinity. Then times exponential minus s, substitute in infinity all over. Yeah, right. Already here we have minus, true or false. So here will now be minus, open bracket, minus sine a, open bracket, 0, right? The lower limit times exponential minus s, open bracket, 0, all over s. Right? Okay? So put the bracket, then minus. Then, okay, let's look at it here. We have minus here, we have minus here. Minus times minus. Let's make it plus. Then we have a constant here. We also have a constant, which is 1 all over s. So 1 all over s times a here. We factor it out, 1 all over, a all over s, integral 0 to what? Infinity, exponential minus st, cos AT dt. Yeah. Do you agree with me up to this point? Amen. Do you agree with me up to this point? You agree with me, right? Okay. So far, so good. Yeah. So far, so good. If you agree with me up to this point, yeah. Yeah. That's mathematics for you. Hope you are following. Okay. So let's proceed. Okay. Yeah. So, because of infinity here will be 0 of this place, then this one times this is plus. Then here, a times this is 0, then sine 0 is 0, right? Here is 0. Anything raised to plus 0 is what? Is 0, right? Oh, anything raised to plus 0 is 1, right? So here is supposed to be 1 all over. Okay, so all of this place will be 0. Then let me just break it down. This one times this plus. So sine a times 0 is 0. Exponential minus s times 0 is 0 all over s. Then plus a all over s. Integral, integral 0 to infinity. Amen. Then exponential minus st cos at dt. So as you can see, sine 0 is what? Is 0, right? Then this is 1. True or false? 1 all over s. So 0 times 1 all over s. This is what it will look like. 0 times 1 all over s plus a all over s. Integral 0 to infinity. Exponential minus s t cos at dt. Amen. Are you following? Do you understand up to this point? Amen. Any question? Do you have any question? Yeah. No question? Okay. So we can proceed. Yeah. Let us proceed. So unfortunate that the network is not friendly. Okay, yeah. So if you agree with me, this one will give us 0. So this is what we left. So here now be equals to a all over s integral 0 to infinity exponential minus st cos at dt. Yeah, but I told us that we are going to, after this, we hold this one constant. So it means if we want to add them up, this is how it will look like. Here will be 1 all over s, then minus a all over s, amen. Then times this a all over s, then integral 0 to what? Infinity exponential minus st cos at dt. Do you agree with me? So if we multiply this, what are we supposed to add? Huh? What are we supposed to add? Look at it very well. Amen? So if you can see what I am saying, here we are going to have this. We will still use parts here. So here we are going to have this is equals to 1 all over s minus this time this a squared all over s squared integral 0 to infinity, then exponential minus st cos at dt, right? So we are still going to use by part, right? Two of us. Look at it very well. I will still use by parts if you can see what I am saying, isn't it? So let us use by parts. If we use by parts here, it means using by parts again. You can clean this, right? Look at the board very well. Look at the board very well. Look at the board very well. So I can still use by parts again, two of us. So let's use by parts again. Okay, amen? Yeah. So if we are to use by parts again, it means we are going to have, we now say, we are going to do this one constant. We now say let u be equals to cos 80 and the v be equals to exponential minus st dt, right? So let us differentiate this with respect to u all over dt. With respect to t, we are going to have minus a sine 80, right? Okay, then du will now be equals to minus a sine 80 dt. Then integrate both sides. You have an ordinary v as minus exponential minus st all over s. Am I right here up to this point? Are you following? Are you following? Do you understand? Do you understand, right? Yeah. So if you can see what I am saying, so we have to substitute in here. So if we have to substitute this here, it means, okay, is there any need for us to differentiate further? Is there any need? Yeah. Is there any need for us to integrate it further as we have here? I want us to understand it. Look at the board very well so that you can see what I am saying. Is there any need? Because if we integrate this function along the line, we are going to have what? Something of this form, if I'm not mistaken, two of us. So just look at it. Let's learn together. Should in case you come across this in exam or anywhere, look at it. Okay, let's look at it together. Let's continue. Okay, so here will now be integral 0 to infinity minus st cos a dt dt now be equals to ordinary v u is cos 80, right? Cos 80 times minus, okay, because of the minus sign. Let's write the minus before cos 80, then times exponential minus st all over s at 0 to infinity, true or false? Then minus integral 0 to infinity, ordinary v is minus exponential minus st all over s times du is minus a sine 80 dt. True or false? It's true, right? Okay. So here will now be, look at it together. We subtract the lower limit from the upper limit. So it will now go this way, minus cos a open bracket, anywhere you see t, you substitute in infinity minus s open bracket infinity all over, then subtract the lower limit from upper, so it will be minus. Mind you, there is negative sign here, true or false? So leave it in the bracket, cos a open bracket, anywhere you see t, you write what? 0, right? Then exponential minus s open bracket 0 all over s, amen? Close bracket, yeah. In between, that is, sorry, inside the integral we have negative, true or false? So minus times minus is plus. So here minus will still exist. So integral 0 to infinity, then this one will now, okay, let's do it this way. Since we have a constant s here, 1 over s is a constant, a is a constant, we can factor it out to give us a all over s integral 0 to what? Infinity exponential minus st, or whichever we want to write it. If you want to write sine 80 first, yeah. So without loss of generality, you can see that here is automatically 0 because of infinity, and here will be plus, then cos 0, this one times this 0, cos 0 is 1, then here will be 1 all over s, true or false? Yeah, true or false? It's true, right? Here, 1 all over, yes, then here we are going to have minus a all over s integral 0 to infinity exponential minus st sine 80 dt. Am I right? Because here will be 0 plus 1 all over this. Yes. So far so good. Yeah. When you look at it, look at this question very well. It seems we are repeating itself again and again. True or false? True or false? Look at it very well. If you know you were in the beginning of this, I think you should understand what I'm trying to talk about. Yeah? Yeah. This thing is, that is why I asked a question, but I just want us to have the basis. It means we are going to integrate this function continuously. True or false? True or false? It's true, right? Yeah. We will integrate this function continuously. That's just the truth. Yeah. That is just the truth. We integrate it continuously. Yeah. Co-integrate this function continuously. Yeah. True or false? Is true. It's true. So, gentlemen and ladies, I'm not going to finish it. Yeah. We are going to look at it one after the other. So, you go home and sit down and go through this. Go through it. Yeah. Go home, sit down, and go through it. It means we are going to, it means let's just join everything together. Mind you, we took this from here. So something here is constant here. So everything will now be 1 over s minus a square all over s squared. Am I right? Then times 1 all over s minus a all over s. Yeah. So integral 0 to what? Infinity exponential minus st sine at dt. Am I right? So look at it. Look at it. Go home and look at it if you can see what I am saying. I'm not going to finish it.